This isn't like a hypothetical, oh yeah, just trust us. It's gonna be good, it'll work.
Welcome to Inside the Build, a podcast series that dives deep into how Forj Medical solves complex manufacturing challenges, told by the people whose knowledge, expertise, and ingenuity make Forj Medical the partner medtech companies trust when the technology is complex and the stakes are high.
I'm Aaron Harpster. I'm a product development engineer at Forj Medical.
I'm Mike Cook, program manager with Forj Medical.
The best way to describe what the segmental project is a new product design and design for manufacturability effort that Forj Medical partnered with this OEM on. We redesigned a large swath of the components, all the way from individual electrical sensor components up to the molded components that housed them.
What key aspect did you have in that?
Yes, so I'm a product development engineer here. This project actually started back when I was in manufacturing. So the first that I saw of it was the actual coils. This product is a bone screw that is used during a procedure to track the location of individual spinal segments. Normally in previous spinally tract procedures, they have to assume that the whole spine is one piece, but that's obviously not true. And so this product gives you the ability to segment the spine. We've given it the kind of the code name of segmental. So it's the segmental trackers. The very first thing that I saw in this project was the individual EM sensor coils. I was the manufacturing engineer for the coil winding, so I got to see the print, and it was a very small sensor, at least much shorter. I think it is still the shortest sensor that we do, and it was a pair of round cores with 58 gauge winding wire on it. There was a lot of manufacturability issues with that. We did end up making some prototypes of that design, but we also proposed an alternative design. I believe at this time we were only being approached for the EM sensors, but eventually we ended up doing the entire design of the segmental tracker and doing the full assemblies up to the point of sterile pack.
Perfect. And so what that's pretty much showing is that our customer had faith in us being able to take this initial concept and bring it into full vertical integration through manufacturing the caps,
yes.
sensor assemblies, and then all the way through the assemblies itself and into the screw assembly as a complete package, all the way to the point of sterile packaging and then ready for customer facing.
Once we had basically taken on the entire project, and we were able to redesign some of the components, the actual the oldest print that I've seen is different than the first one that I saw.
Yeah.
The very oldest print was intending to reuse a lot of existing materials and components. This OEM had and still has a bone screw they were using for a previous generation of this of a similar tracking product, and so they wanted to just reuse that entire component. And so they had designed the carrier that the coils were going to be mounted to around that screw. That was a very complicated design, and I believe some of the conversations other engineers had with them ended up with them redesigning the actual bone screw component. So instead of going through the entire assembly, it was mounted onto the front. Now, I do think that was a very positive redesign in terms of manufacturability, and especially moldability. Some of the original, and this is at the point where I started to see it. The design that I saw had, instead of having the screw go all the way through it had the cable that the sensors would be connected to going up through the center, and then the cable wires would be routed around like a top edge of the carrier. And then the coils actually had like kind of a bossed channel. It would have been a little bit of I won't say a molding nightmare, but it was definitely more complicated than it needed to be. And I can for sure say that the assembly of the coils onto the carrier would have been very difficult. One of the things that us doing the entire design let us do with the design for manufacturability was replace the entire concept of placing the coils on the carrier directly with creating almost not quite a surface mount component, but a coil package that is much easier to handle. When you're trying to attach this 58 gauge wire to larger twisted pair, you need to have it creates delicate joints, and so after it's been attached, you want to move them around as little as possible. What we ended up doing, we were experimenting with making surface mount coils for navigation. That hasn't ended up going anywhere. It was just kind of an internal tech dev project, but it did show us the possibility of directly bonding the winding wire from the coil to a PCB. I ended up reusing that concept to make almost a small chip that has this coil mounted on it. This one ended up going through a few different design iterations, but we thermocompression bond the lead wires of the coil directly to a PCB, and then that gives us solder pads that we can solder this twisted pair to from the cable. Yeah, it's been a huge jump in terms of manufacturability, trying to make those bonds after you've already glued if the original process would involve gluing the coil into this channel, and then you need to make either solder bonds or thermocompression bonds with this really delicate wire, somehow glue it down to the outside of this carrier. But by replacing that with putting the coil directly on a PCB and then having basically an encapsulated package that we can move around and position on the carrier after it's already been attached, we can remove this high-risk step of, okay, we have 3 coils attached to a carrier. That's a lot of cost. If one of them screws up, right, if we screw up the bonds on one of them, now we're scrapping 3 coils instead of just one. It allows for the possibility of rework, but it also gives us just a better process flow. We can panelize these coil assemblies, so we get sheets of 25 of them and come back later and just cut them out with a laser. It's a fantastic process, I think. It's not quite as good as what I was originally envisioning. I had some delusions of being able to automate something at not a super high volume, but I had dreams. It's been a really fun process.
So it sounds like the customer came to us with an initial idea. They already have it in mind. What we did is we did some analysis of that process. We understood kind of where the gaps were at with their current design.
Mm-hmm.
We brought them through the process, explained to them where the benefits would be in improving the design and the manufacturability, especially as they look at ramping up into sustaining manufacturing and allowing them to actually have a true ramp plan and being able to take the process they had, modify it to make it more manufacturable, which then allows it to be an easier process for our manufacturing team to actually establish a process to put together.
Yeah, correct.
Perfect.
I mean, it's not like their original design wouldn't have worked. It would have been functional. But allowing us the opportunity to redesign it let us bring costs down a lot. One of the things, even back to the original coil design, we were experimenting with replacing that dual core of the coil with a single piece that was shaped as the same as having 2 cores next to each other. Way less handling, because either you need some way to attach these 2 cores together after they've been annealed, or you're heat shrinking them together, or you need to somehow hold them next to each other while you're winding the coil. Those were things that we were able to solve at very small scales, but it would not have been a scalable manufacturing process. Now that shape, that like non-circular shape, was a requirement. I believe it had something to do with noise mitigation. I still don't fully understand all the physics behind it, but they claim that their system can do the math a bit better and cancel out the noise, so I believe them on that. So we came up with a shaped core. We were able to quickly prototype that by essentially just reforming some existing wire that we had. But then we were able to work with our suppliers to get wire that was shaped directly to that size. So we were able to prototype and prove out this design change. And I think the cost ended up being about half per sensor. And with 3 of them in this full assembly, it was not an insignificant savings. Yeah.
No, that makes perfect sense. And what that does is it shows the customer the importance of how having a design group within the manufacturing facility allows for us to take the concept, revise the process, prove manufacturability, and then release into our manufacturing facilities. And with the vertical integration we have here, from plastics to winding to assembly, it allows everything to be under one house, which also reduces the cost and reduces the handling, having to transfer from facility to facility as well.
And not to mention the fact that we were familiar and we do a lot of PCB assemblies, even though this isn't really a traditional PCB assembly, it gave us all the existing equipment where we could just, we have a laser depaneler, we have solder printing, we can just run this part through our existing equipment. It allowed us to improve the manufacturability instead of requiring a large investment in some new equipment to, gain a 15% improvement overall, right? It can be a tough sell sometimes if you don't have some of that capital equipment already.
Yeah, it was right in the wheelhouse. So it allowed for easy onboarding, and also allowed for us to ramp into manufacturing. So as a program manager, my goal is to take everything you're throwing together, create a timeline, make sure that as we hit milestones, we're able to release into manufacturing and get the customer their released product in a timely manner. So that's what we were able to do, is with all the hard work you did up front, we were able to take that, bundle it into a nice package, create milestones for release into manufacturing, and now we are manufacturing this product at a higher speed. So it allows for the customer to receive that finished goods at a more consistent basis now.
Yeah. The ramp of this has actually kind of taken me off guard because I haven't been super involved in the qualifications. It's one day it was just like, we're making these coils now, and it's like, oh, great. It's actually been a little bit annoying at times because I've been expecting to be able to use this winder for some other development work, but it's actually been really good to see that it's just, we're getting into production.
Once again, that goes back to our vertical integration and how the close-knit community between the two groups, design engineering and manufacturing, it allows for us to take that concept, prove it out, put it into manufacturing, and then launch into sustaining manufacturing to manufacturable assembly demand. Yeah.
And I think one of the other big changes actually kind of comes down to the plastics and the molding. The original carrier component that I saw, I think had a mold that required like 4 separate cams, and had features that required the mold to pull away from the part in like 6 different directions. So you have the A and the B half, but then also there's all these other features where it needs to like lift off the part for it to be able to eject. I ended up managing to get it down to just a 2-part mold. There wasn't any other cams or moving parts in it, which I'm personally really proud of. The cap that goes over the top of the carrier after all of the coils have been connected, that still does have a single cam. We're able to redesign that component to accommodate these printed circuit boards with the coils attached. That went through many iterations. It was really good that we had a quick turn PCB house, because these designs were coming out pretty fast, and that, along with our laser depaneler, was really, we were able to crank through iterations on almost a weekly basis. And some of our 3D printing technology at the time, we were able to get some pretty high resolution resin prints and try this out and prove all these components and show to the customer, hey, this design change will work. This isn't like a hypothetical, just trust us, it's gonna be good, it'll work. We were able to show that, we can hold all the angular tolerances even with these 3D printed components, It'll only get better with the molded. Yeah, there was a lot of potential with issues when you're making these large design changes. It's like, okay, how accurately can we position these coils? That was a big requirement for this segment tracker. Being able to do these prototypes and knowing that I can talk to our molding team and check with them, okay, this design will work. This design of carrier you can mold this. I don't need to worry about, internal radiuses, being too large, or I was able to check with them as I was doing the design iterations. And I got to learn about how molded components are designed. It was my first time designing these two, and it worked out really well.
Perfect.
Having that expertise to rely on.
Yeah, the collaboration between the manufacturing groups and development engineering really helped us take that process and actually redefine it in a timely manner that allowed for the customer not to lose any steps in their release to their patients as well. So
yeah, we ended up getting all the design changes we wanted. There was because these are packaged in a 5-pack. They each need to be different colors. We were originally really pushing hard to get different colored cables, but it ended up being that there's a heat shrink layer that gets applied for coloring. So it's these little marker color bands, basically. That's the one thing we really wish we could have changed, but it ended up getting through. There was the existing cable was a legacy component, so that ended up still just being used. So we don't always get everything we want, but we wish we could.
Yeah, and now with the partnership that we've created to bring out Forj Medical, this just shows kind of how we take that design manufacturing into component manufacturing, and eventually we'll bring that more into top-level assembly and be able to take that vertical integration from design to top-level assembly in-house.
Yeah. With the recent merger into Forj Medical, there's a lot of opportunity with also doing capital equipment. I've always just been on like the disposable end effector side, but also be able to integrate more thoroughly with the capital equipment, I think is going to be a big advantage.
So then with the redesign that we were able to assist our OEM customer on, what improvements did you see along lead times and ease of manufacturing? Yeah,
I think one of the big things is just improved lead time. We're not waiting on an external molding house to get our molded components. That's actually been one of the big issues is lead times with some of the machine components, because we don't do the machining. So we haven't had issues with lead times for molded components, and having all of the solder printing and PCB work in PCB design ability in-house. That's been great for reducing our lead times, and the great relationships we have with PCB suppliers has been really beneficial too. Getting their input on manufacturability of the printed circuit board design.
The biggest questions from a customer is always, how are you going to, reduce the cost? With the redesign that you did, it made it more easy for the assemblers to manufacture, which brings our skilled labor content requirement a little bit down, which allows for it to be more widely easy to assemble, which will reduce the overall cost.
Yeah, the combination of the redesign and some of the incredible work that our fixturing design engineers have been doing has really reduced the skill required to do one of these surgical navigation assemblies. Normally with the really fine wire, we have just a handful of operators that can do it, but this has really widened the ability, or the skill range that's required for this design to be assembled. Really reduce the cost.
Perfect. And what that does is it allows for us to actually look for some of our current assemblies as we're starting up our Costa Rican facility. And so by allowing it to be easier to assemble, it allows for that startup actually across the sea to actually happen. Or
the reduced training time
down in Costa Rica to actually allow that to take off too.
Yeah, the reduced training time really opens up the ability for line transfers. We were envisioning the entire time of this development that it would get transferred to Costa Rica, as that was around the time we were opening that plant and building it out. So we've always been keeping in mind how are we going to transfer this? How are we going to be able to train new people who've never worked in this kind of world before? We wanted to make sure we weren't relying on some of our most skilled operators to make it possible, which the original design certainly would have required.
It allows for us to actually be able to support from afar as well.
Yes.
As we start to ramp up in Costa Rica, it's going to allow for us to be able to have that technical support from a remote setting and make it a little bit easier versus having to be hands-on and explain some of this more technical aspect of it.
Yeah. Yep.
Perfect. So what key things to look at from a customer standpoint is cost, delivery, being able to send it down to Costa Rica with a more simplified design, allowed for us to reduce the cost, which is important to the customer. Vertical integration has allowed for us to make it faster, have less lead time because we are not relying on an outside source of components. And then that allows for the customer to receive it in a shorter lead time as well. So cost and delivery are kind of the most important things to a customer.
Yeah.
And so from a holistic program standpoint, it allows it to be a winner for the Forj Medical group because it allows us to hit the customer key points and allows us to vertically integrate from a design and also transfer our line down to our Costa Rican facility.
Yeah. And the vertical integration really opens up so much more in the design space, because we're not just familiar with all of the different aspects of the design. We're experts. And so we know what's possible. Where can we push the boundaries of a molded component? Where can we push the boundaries of an EM sensor? Where can we push the boundaries of a printed circuit board and a PCB assembly? It lets us do things like the segmental tracker.
This has been Inside the Build, podcast series by Forj Medical, where we're shaping the future of life-saving devices, one build at a time. Thank you for listening. For more information, visit us at forjmedical.com.